All of you have come from Algebra 2, which means all of you have seen function composition. So this should be a review, but that's okay. I'm going to teach you like this is the first time you've seen it. Here's our notation for function composition. I have f of g of x. This is one way to write it, like this, with this little circle, makes it look like fog. And another way to write it is where you have this function inside of another function. The confusion comes where you're not paying attention and you think this is a multiplication problem, right? We're used to seeing numbers next to each other to represent multiplication. Kind of looks like multiplication here, doesn't it? Well, that's not what this represents. This represents a function, in this case g of x, is being placed inside of another function. Now, what I mean by inside was, I'm talking about the function of x. So it's placed, and you're making a replacement of that variable x with another function. And I'll go over what that means. Also, you see the notation of, like you said, fog, which that's what it looks like, right? Well, I think this was based on how you word what this means. This is the function composition of f of g of x. And I've been saying all year that math is kind of lazy, so they didn't want to have to write all this. So by taking away this f, you're just left with a O, or in this case, open circle.
Mr. Clark, is your is this video old? The section 2.8?
Yes.
That was you when you were young.
Well, I don't know, 2 years ago. But let me show you how this works. So I have my function f of x equals x plus 5, and g of x equals negative x squared minus 5x. I want to find f of g of negative 4. So how we work is, first I need to work out the problem here. We want to work from the inside out. I want to find g of negative 4. Well, we've done function evaluations, so you should know at this point how to find g of negative 4, which means I'm taking my values of x of this function and doing what?
Values of x for the function.
To find g of negative 4, what do I do with this negative 4?
Bring it down. Bring it over.
Switch it.
Multiply it.
Switch sides.
Replace x
Replace x
with negative 4, right?
Yeah.
So I have negative 4 squared minus 5 times x, but now I'm replacing x with a negative 4. So this is the first thing I need to do. I need to evaluate g of negative 4. So this gives me, let me switch color. This gives me a negative 4 squared. So negative 4 times negative 4 is a positive 16. Add that to negative 5 times negative 4, which is a plus 20. And what is negative 16 plus 20? That is 4. So what is the solution to g of negative 4? 4. Now what I do with function composition is I take my original composition here, f of g of negative 4. I now found what this value equals right here. So I am now going to replace f of negative 4 within this function with the number 4. So f of 4. See what I did there? This is the confusing part. G of negative 4, we need to evaluate that. I did, and I found the value of 4. Now let me replace g of negative 4 with this value, which is 4. Now I need to find f of 4. So let me look at f of x, which is x plus 5. And instead of x, I want to replace that with a 4. So I get f of 4 equals 4 plus 5, which is 9.
I don't know why I was gonna say 1.
Well, maybe you thought that was subtraction.
No, it's because I seen the little equal sign next to the 4, but I only seen 1. So I
Okay.
negative 4 plus 5.
Yeah, okay, I see. So, okay. Function composition, a function inside of another function. I want to work from the inside out. So evaluating g of 4, which is 4, replace that, find f of 4. Plug 4 in for x. 4 plus 5 is 9. So what is the function composition of f of g of negative 4? It is 9. So essentially it's two problems in one. I could have asked you evaluate g, oops, what's going on here? 1 second. Like last time. There you go. I could have rewritten and asked you to pretty much solve the same thing by asking for g of negative 4, find that value, and find f of 4. You would have solved g of 4 and found 4. You would have solved f of 4 and found 9. We're doing the same thing, but kind of a lazy man's shorthanded way of doing it. Putting one function inside of another. So let me demonstrate this again, and maybe you can help me out. I have two functions, g of n equals n plus 1, f of n equals n squared minus n. Find g of f of 8. So what's the first thing I want to look at? First thing I want to evaluate. F of 8, the inside function. So let me go here. F of 8 equals n squared minus n, which is 8 squared minus 8. 8 squared is 64.
Who the hell is that?
Minus 8. 64 minus 8 is 56.
No, I'm just kidding. I didn't.
So what is f of 8? It is 56. What should I do with that value 56? Plug it in where? Yeah, plug it in place of f of 8. So that gives me g of
56.
56. Very good. 56. Like so.
Why did I say f of n though? Is that just a, that's just a...
This is just a function.
Okay.
I'm replacing the variable n
Which is
with
x.
8, and I'm solving, which I found 56. Now g of n is just a function, and now I want to evaluate g of 56. So g of 56 equals n plus 1, so it's 56 plus 1.
57.
57. Yep.
Excuse me, sorry.
So what is g of f of 8? Well, that is 57. By first evaluating f of 8, finding that value, and finding g of 56. And calculating that value. 57. All right.
Okay.
Now it can also happen like this. I can put the function inside of itself and evaluate. So g of x equals 2x. Find g of negative 3. So what would be step number 1?
Look at the inside number you said?
Yeah. So what am I evaluating first?
-3.
G of negative 3. So g of negative 3, 2x, equals 2 times negative 3, which is negative 6.
And you replace it when you do it again.
So what am I'm doing what again?
Bringing it to the over there.
Okay, so what am I trying to find? G of
G of
negative 6. Very good. G of negative 6. Again, now I'm plugging it back in to that function. And let's look. G
like that.
of negative 6 is 2 times x, in this case negative 6, which is negative 12. So what is g of negative 3? Negative 12. I get asked a lot, of course, when would you ever use this math in real life? Well,
Nope.
you would not have ever broken it down like this in your head and use this kind of format, but you do function composition all the time, every day, constantly. What's going on is, I need it, before I do this operation or whatever it is, I need to first calculate this. So think if you have a shirt that's on sale and you want to figure out the total price. Well, first, you need to calculate the sale price. So if I have a shirt that costs $50 and it's 10% off, I need to figure out how much is the sale price. 10% of 50 is 5, so the shirt is now $45, and then I need to calculate the tax. So what's the tax on $45? That's function composition. You have to do something first before you can calculate the other part. All right, so while I take attendance, let me have you find g of h of 8. What function do I want to calculate first, or evaluate first?
8.
H of 8, right?
Yeah,
H of 8. My h function is 2n plus 1, so that's equal to 2 8, or 2 times 8 plus 1, which is 16 plus 1, which is 17. So h of 8 is 17. What do I do with this value? Plug it right in for g, or replace h of 8 with that value. So 17. Now I'm looking for g of 17. G is 4n, so 4 times 17 minus 5, which that is what, 68? 69? What's 4 times 17?
67. Hold on. What's my calculator?
68.
68, thank you.
I was 1 off.
68 minus 5 is 63. Did we get 63?
Yes.
All right, very good. So that is evaluating function composition. All right, so I have two functions.
This is so easy.
I have two functions. G of n equals 4n, f of n equals 4n plus 2. I want to find g of f of n. So we're not evaluating. I want to place one function inside of another and see what new function I get out of that. Think of Kirby. Kirby sucks something in. What happens? He becomes like that character, right? This is essentially what's going on here. So, when we're evaluating, we work from the inside out, right?
Yeah.
Find this, work out. When you do it like this and you have nothing to evaluate, you're just trying to find the new function, you kind of want to work from the outside in. So let me look at the outside. I have g. So let me rewrite g. G of n equals 4 times n. With me so far? I'm just writing g. That's my function on the outside. What happens with f of n is replacing my variable. This variable is just a number, right? I could put anything in here for a number. A function is also a number, correct?
Yeah.
Like f of n. So I can put that inside of my new function. So this is going to go right in there and right in there. So g of f of n, so I'm replacing all my variables of g with my function. So I'm going to replace this n with what?
4n plus 2.
Very good. 4n plus 2. See what I did there? Function composition. You're replacing the variable of one function with a completely, entirely different function. Now you just have to simplify. So let me distribute. 4n times 4 is 16n. 4 times 2 is 8. So what is the function composition of g of f of n? That is 16n plus 8. Completely new function, just like Kirby. One function goes right inside another function. Maybe that's too misleading, I don't know. Maybe it would be better if I just show one arrow there. All right. Let's look at that again. G of x equals 3x plus 3. F of x equals x cubed minus 3x squared. What function am I putting inside of another? I'm going to put f of x, which is x cubed minus 3x squared, and where am I putting that? Very good, in place of x. So g of f of x equals Here's my g value, right? 3x plus 3. 3 something plus 3. That something is going to be this function now. Like so. This f of x value goes inside of there. And like last time, to finish this off, we just need to simplify. So 3 times x cubed is 3x cubed. 3 times negative 3x squared is negative 9x squared.
Ooh.
And I have this constant 3. There are no like terms, so that's my solution. I could factor out a 3, but that's overdo it, at least for today. Now, what if I were to write this backwards? I'm not going to solve it, I just want to make an example. So I have, f of x, and inside of that is going to go g of x.
And you put 3x plus 3 inside of the f, or where gx,
So
g of x
where am I putting it?
inside of the parentheses where f is.
Okay, I can put it here.
Yeah.
So that'll be the same as writing f of g of x. Where else can I put that inside the actual function? So you tell me I need to replace this x. Is that the only x I need to replace?
No.
No. What other place am I placing 3x plus 3?
G of x? No, that equals.
I'm putting g of x inside of my variable for f of x. So where are my variables for f of x?
I'm trying to find
Anybody help them out? I'm trying to find g of f of x.
G of F.
Yes. He's already told me you're going to replace the x value of this function f of x
and
with
then
3x plus
put that
3.
into G of f of x, right?
And then plug
Where would I plug in 3x plus 3?
and the x for x cubed.
Okay, so again here, for this variable x,
Oh.
so that's going to be 3x plus 3 cubed instead of x cubed. Is that the only place you put it?
No,
No, I didn't say that because we said
And
that.
then here too. So negative 3 times x squared, and in this case it's going to be 3 plus 3 squared. And that's how you would do the function composition of f of g of x. Everywhere you have an x value, you need to plug in that function. I'm not going to calculate that because that would take a moment. But I just want to show you it needs to go everywhere. One more thing with function composition, a special case, which you should have saw in Algebra 2. I have two functions here, f of x equals x cubed, and g of x equals the cube root of x. What happens when I put one of these functions inside of another? Note, what do we know about these two functions?
They'll cancel out.
They're canceled out. Why? Because they're
Cube, and they're opposites.
opposites or inverses from one another. Now note, I did change the notation. It now looks like this. So which function goes inside the other?
G goes inside of.
As you see here from our template,
Oh.
the function that has the variable next to it is the one that's inside. So pay close attention to this because this is kind of confusing format to read. It's not as clear as day as this one. I can see f of x is inside of g of x, but I can't see that here. We're going to grab the function that is closest to the variable. That is going to be your inside function, okay? Sorry, that's a little hard to read, but this is the notation math geniuses, whatever you want to call them, the math gods came up with. So let's go back to this problem. Which of these functions is the one in the middle? F or G? Which of these functions is the one that's going to be inside? G, very good. It's the one next to my variable x. So I'm going to go ahead and write G. So that's the cube root of x. And I'm going to put that inside of my f of x, which is x cubed. So f of x equals something cubed. And what happens when you have the cube root of a number cubed?
Doesn't it turn to a square?
Cancel that.
Cancels.
Times 2 x.
Yep. And all I get left is an x. Very good. Y'all remember that from Algebra 2. So this leads into a interesting thing. If I had the function composition of a function with this inverse, what I get out of that is just the variable. These
Cancel.
will cancel. Yep. So as we look at this next problem, what's the solution? I have f of x equals x squared, g of x is square root of x. The function composition of f of g of 16 is
16.
16. Yep. Because these two would cancel and just leave me with 16. Now, if you didn't see that and you want to work this out, which one would I work first? Or which one would I evaluate first?
F of X.
Nope.
G of X. Sorry.
This one, right? This is my insight.
F of G.
The one that's closest to the number. G of 16. So g of 16 is the square root of 16, which equals 4. Now what am I going to do with 4? I figured out what this is.
Put it inside F.
Now I need to put it inside f. So I'm finding f of 4, which is 4 squared, which is 16. So if you didn't remember this rule right here, where a function inverse inside of a function cancels, then you could work this out and get the same solution. 16.